Hey guys, in this video, we're going to cover everything there is to know about awk. We're going to give you all the time-saving secrets and tricks and tips to make your life easier on the command line. So if you've ever used awk before, you've probably only used it to select output columns and to split apart command output, parse things, stuff like that. But you might not be aware, but awk is actually an entire mini language with tons of syntax and functionality. Now, we're going to cover all of the tricks that save you a ton of time in this video. We're going to be covering basic commands, field separators, matching, filtering, counting, replacing, creating awk scripts, flow control, arrays, loops, and a ton more stuff. So for all these great tricks, just keep watching. Watch this whole video through, and by the end, you should know pretty much everything you want to know about awk and probably a lot of things that you don't want to know. But we're going to try to keep it down. We're going to try to focus on the important stuff that you do want to know. So if you ever wanted to make sure you just know everything about awk, this is the video to do that in. Now I'm going to cover this document right here. So this is the document that I wrote a little while back, and if you want to find this document, I'm going to put the link in the description of this video. So just check the link in the description, and yeah, you can read this document for yourself. So in any case, I'm going to go over some basic concepts about awk really quick, and then I'm going to switch over and zoom in on this terminal, and we're going to be demoing the commands here in just a minute. So about awk. Now, there is some confusion for some people about the difference between awk, knock, and gawk. Now, awk is the original command from AT&T from way back, probably in like the 80s or so, but it's more historical. And you're actually going to be running the awk command on most modern systems, even though you're actually either going to be using gawk, which is GNU awk, or knock, the newer version from AT&T. This is what you're going to be getting on BSD or OS X or newer Mac OSs. And gawk is the version from that you're going to have on most Linux systems, which has a few extra features not in awk or knock. Worth being aware of. Now we also have some installation instructions here, so you can install it if you don't have it on your system. You can even compile it yourself if you want, but you don't really need to do any of that because pretty much every system I've ever come across has already had awk installed on it. So any case, let's talk about the core functionality and the way awk works. So basically, the life cycle of an awk program. So and this is probably seems a little bit strange if you're used to just running it as a quick command that you pipe information into on the command line, but basically you run commands in the begin block, and then you loop until the end. Basically, it will just loop through the end of through whatever file you're operating on, or if you're piping output into the awk command, it'll just keep looping until the end of that information that's being piped into it. So basically, for each loop, it will loop once per line, and it will read the line and execute commands based on that line that you read in, and then it will, after it's done looping through each line, it runs commands in the end block. So basically you got your begin block, loop through all the lines, execute a command for each line, and then run the commands in the end block. Now this is what the basic format looks like. You have your begin awk commands, and then you do in the middle, you basically, when you're looping through, you're going to have like a pattern that you match, and then commands you run based on that pattern. So you'll only match certain patterns or split on certain things, and then you will run commands on them, like print a certain column or whatever else. And you can like replace characters and other useful things. Then you're going to have your end block and run some final commands at the end. Now, here we're going to be jumping into the actual commands, so I'm going to be moving this document aside, and I'm going to zoom right in on the terminal here, and we're going to get to work. All right, so let's get started with basic commands and basic syntax. So the most basic thing we could do is basically we're going to start with piping the output from the ps command to the awk command. So we're just going to filter out columns. Now you see here, run the psef command, and you can see a bunch of processes running. This is just output showing the processes running on my system. Now you see there's a bunch of columns separated by white space. Now you could select and print these columns. So the most basic example of an awk command would look like this. Now you're going to run psef, and you're going to use the pipe You're going to pipe the output of that command into the awk command. And we're going to show you how to do this with files too in a little bit. But you're basically going to run awk, and then your most basic thing, you're going to have single quotes like this, and within your single quotes, you're going to have your command, and in your inside curly brackets, basically exactly like what you see here. And in this example, we're going to say print, and then we're going to specify the columns we want to print, separated by commas. So we're going to print column 3, column 5, and column 7. So there we go. We see those columns have been printed. Now, if we just look at the basic output, that prints, let's see, column 3 right here. So this is going to be, yeah, let's see, what did we do? We did column 3, 5, and 7. So yeah, 3, 5, and 7 here. So let's say if we wanted to alter that to be column, let's say if we wanted to make that column 8, and let's say if we wanted columns 1 and 2. This is probably a better example. So we can get these columns here. So notice you have like your user, UID, and the description. Now, interesting thing that I should point out here, notice how these commands, this shows the actual program that's running. Some of these are separated by spaces, and when an awk, rather than just giving you this whole thing, it doesn't know that this whole thing is supposed to be one column, so it will parse it out, and when it's taking your 8th column, it's going to take just this part, and this parameter here is going to be a whole separate column. So you'd need another way to parse that out, and we're going to show you how to do that a little bit later on too. Now, the other thing you can do, you can separate these. Now, basically putting a comma in here between each of these fields will automatically separate them with a space like this. There's a space between each field. Now, if you didn't want to do that, you could take the columns away, and they're going to be separated by nothing, right? Now, what you could also do is you could separate them by a string, an arbitrary string like this. Notice that adds a space in there. Now, we could also add a space in here and end up with the exact same result that we had before. Or you could add a ton of spaces if you wanted. Or you could add any arbitrary separator you want in your output, like, for example, something like that, which is kind of nice. So this lets you format your output in any way you want. So you could add a string like something like this into your output, and it's going to come out looking like this, which is pretty nice. And keep in mind, all of these commands I'm typing and all these examples, they're in the document that I wrote. So I'm basically doing all of the stuff I'm demoing is based on the document. I'm actually just reading off of my document right now. So if you want to look at any of these snippets of what I'm typing in or any of these commands I'm using, just check the link in the description to my guide. It has all of these commands I'm typing, and it shows you all the syntax and everything. So you can just copy and paste my commands and run it for yourself on your own system. Any case, let's I have a file in this directory called test1.txt. Now it looks like this. It's split up by now this is just arbitrary data. Most of this is made up and doesn't have any meaning, but it's based off of like an exercise spreadsheet, right? So exercise and health and stuff like that. Anyways, a bunch of the data is just messed up, and I just filled in a bunch of the blank spaces with garbage data just to have something to work on to do for demonstration purposes. Any case, we're going to show you how to what we could do is we can select columns. We could cat this file out, and then we could cat it into, and we could pipe the output into awk like this. We could say print $. Let's see. Let's set what column do we want? 1, 2, 3, 4, 5, 6. Let's say column 6, right? So let's say if we want to do $6 and only print this column, right? We can basically select out this one column, and notice that was this column here. So that's how we would do that. Now the other thing you could do is you can say, if you don't want to pipe the output from cat, you don't want to use the cat command, you can actually just tell awk to access the file itself. Now this doesn't work if you're just piping the output from a command like ps or something like that, or any other arbitrary command, but if you're operating on a file that you would have been catting, then it makes sense to just tell awk to access the file directly like this. So you can actually say awk, the command you want to run, in the file you want to operate on, and there you go, same result. Now The reason a lot of people would still prefer to use cat like this is because a lot of times you're going to be concatenating commands together. You might pipe to awk and then pipe to grep and then pipe to awk again and do a whole bunch of other things. Generally, you chain a ton of different commands together when working on the command line, so that's why people get used to doing things that way. Now, let's see. Next thing I would want to show you is I'm going to show you this other example that I have, just copying and pasting out of my document here. So you could select columns like 3, 5, and 7 like this. Basically the same thing that we showed you before, except we're specifying the file rather than piping output. In any case, so we can do the same thing with PSEF output. Basically what I showed you before. Separating columns like this, you can basically just print out the columns you want and separate them with an arbitrary string like this. And you can use whatever string you want. Basically, same thing that I showed you before. But for example, if you wanted your output to be like this, you could say field that I selected, just to give you a feel for kind of what you can do. And it's gonna look like this: field that I selected, and there's the field. So, in any case, say if you want to print a header, right? I'm going to copy and paste this example here, paste this in. So we're going to say awk. Now, remember how I mentioned the begin block a little bit earlier on? So in your begin block, you can just use a regular print statement. You can say print column 1, column 2, column 3. And you're separating it by tabs, and then you're saying actually, let me just run this first real quick. All right, now notice, see how this output has column 1, 2, and 3 in the header? Then it has the 3 columns that it selected from our output. So what the command does, it says awk, and then you have your begin block, and you specify begin in caps, and then you have your curly braces, and between your 2 curly braces, you're going to have whatever commands run at the beginning phase. So those commands run once before you start processing the file or whatever data you're operating on. So it's just going to do a printf, and it's going to print out these columns separated by tabs. You see the /t there. It's an escape character for tab, and the /n is a new line character. So and after that, you're going to have the middle section of your program that runs. It basically just runs a command on the line that you're operating on. So it will loop through this entire file, running this command on each line in the file. And so for each line in the file, it's going to run the print command specifying columns 2, 3, and 7. And it's going to also separate those with a tab. So we put an arbitrary string in there. Remember how we had separated them with strings before by putting those in quotes. So you just run a /t for a tab. And then in this case, we have an end block. And in the end block, we're going to specify between these 2 curly braces that we're going to say print done. And notice here at the end of the output, it prints done. So this is what happened in the end block. This is what happened in the begin block. And everything in between it, all these lines we processed, happened in the all of that happened in this middle stage here. So I'm going to drag my document in here real quick. So that's what I was talking about over here. You have your begin block with some awk commands at the beginning, then you have your middle section that loops until the file or the output is all complete, until you've gone through each line one at a time, and then it runs your end block. So that's basically what's going on there. So all right, let's see, moving along here. Let's clear the screen real quick. So those are the basic commands, and that's basic awk functionality. So now we're going to move on to field separators and variables. So let's see here. Let's say if we wanted to separate by a colon instead of a space. Now your default field separator is a space, or I think any white space really. So if you want to separate by something else, like for example, you notice we have colons in here. In this timestamp over here, you have some colons. So say if you go like this, paste this in here, you can split it up like that. So what we're going to expect to see is if we split this by colon rather than by spaces, that your first column is going to be this whole section here. Your second column is this. Third column is everything after that, right? So if you were to run PSEF and pipe it into awk, and to specify the field separator, you do a dash capital F, and then the actual field separator you want, in this case a colon, and then you specify your command like you normally would. Now you can separate the begin, end, and middle. Now most of the time we're only just specifying the middle part. This is the one command that it's going to run for every line that you're processing. So in this case we're printing 1, so we expect it to print out this first column here, which is what it does. Now we could have selected 2 or 3. Right now, let's see what that looked like. Oh yeah. So when I said the first column, it's not this. There's actually another. There's a colon right here too. So first column is here, second column is here, then your third column, then your fourth column. So yeah, your second column looks like that. Third column is like this, and fourth column. Now. Let's see here. Let's clear all this out. And let's see, moving along here. Let's try. Okay, there's another way to achieve the same thing. So I just like to make sure I get this covered. You're probably going to want to do it the first way that I showed you, but just to be complete, you can actually specify the field separator. You can use a -v to include a variable. So -v means you're including variables, and you're going to set the variable fs, field separator. So rather than just using the f flag and specifying the field separator, you can actually assign a colon to the field separator variable. So you're saying, hey, assign some variables. The variable you want to assign is fs equals a colon, and that achieves the same thing. Now, let's say if you want to change it to, say, like a slash or a comma. Let's give that a shot right now. So copy this in here, and there we use a slash. So that's what it looks like. So syntax there, same thing. Put a slash instead of a colon, and you could do the same thing with a comma. It's going to split. Now, it doesn't make a whole lot of sense because there aren't a whole lot of commas in our output, so you're not getting something that makes a whole lot of sense. But if you were parsing, like, say, for example, a CSV file, like a comma-separated file, then using a comma would make a whole lot more sense, right? Whereas you would not want to split on white space. So, for example, say if instead of being separated by like say if this were separated all by commas and then you wanted to print out an entire string like this with spaces, you could do that and you wouldn't be splitting on spaces. Any case, so you can use -v to assign, so you can just set variables. So a little bit more on variables, not the most super useful thing in the world, but it can be. Now you can say awk-v. Remember we used that -v flag just a little bit ago to set the field separator. Well, in this case, you can set an arbitrary variable, say var1, set var1 to the value of xyz. And then in your begin section of your awk script, this is a little inline script. That's really what we're doing when we're running awk one-liners. So in the begin section, we're going to run this printf statement, and we're going to print var1 equals, so this is a string, and then you're going to include the variable right here. So we have modulus s, that's where the variable gets included. So you pass a string, a format string, comma, and your second thing you pass to the printf statement is your var1, which we defined here. var1 is xyz. So you're going to specify var1, and that gets substituted in here where your modulus s is. So in any case, oh yeah, and this is in the begin statement, so it's going to be the first thing that's run, and it's going to be run once. It's not going to be run for every line in a file that we're operating on. So run that, and it just prints out var1 equals xyz. So it's just printing out the value, a label, and the value of the variable that you set. So not too exciting, but that's something you could work into more elaborate scripts. So let's move on to matching, filtering, counting, and replacing. So we can do pattern matching using, basically this is using regexes. There's another section on regexes we're going to cover in more detail later on. But let's show you an example here. Now you can match things. This is actually This gives you similar functionality to the grep command. You technically don't need the grep command. You can actually grep things in awk. So normally people use awk to split out columns. People would use the grep command to grep a certain line. They're going to match a certain line. Then once they match the line they want, they will then pipe that output into awk to split out the columns that you want. But really, you can use awk to do both of those things. You can use awk to split out, to match a line and to split out columns, which is pretty neat. So this first example I'm going to show you is you're going to say awk, and now so far we've basically just been running something in curly brackets, which just tells you what command to run. Your command that you want to have operate on the line you're operating on is in the curly brackets, so that normally we've been printing, and that's what we're going to do in this example. But in curly brackets is your command, and before your command you're going to have something. You're going to have what you want to match. So in this case, we're including this regex for TTY. So we're going to match any line that includes the string TTY, and for each matching line, we're going to print it. Now, note one other thing we're doing different in this example is we are just we're not specifying which columns to print. We're just saying print without specifying the columns. So we're going to get the default behavior of print. So that's going to print the entire line without splitting it by columns. So by default, print will just print everything. It will print the entire line, but it only selects lines with the string TTY. So we have these 3 TTY lines. So like we have our GNOME session and some other stuff. So yeah, you have TTY on this line, and this line, right? So let's say if we wanted to do the same thing, and well first I'm going to I'm going to do the same thing, but I'm going to specify a column. Let's say column 1, 2, 3, 4, 5. Let's try 5 and then try 6. All right, so we're going to say $5. We can print out everything in that column. We can try $6. So we're going to print out those 2 columns. Now, interesting thing, this column on the bottom did not match TTY, but that's because TTY was somewhere else. So that's actually this output up here. The word this is actually the awk command that I'm running, and I had TTY in the awk command itself, so it's matching itself. But other than that, it's just matching things that have an actual TTY. But this one was actually on PTS, which I believe is the terminal that the virtual terminal that I'm logged into right now. So any case, just good to know. Now another thing I wanted to show you is that instead of all of this, you can actually remove the command that it's supposed to run and just match TTY, and that also will print by default. So whereas with this you can print and it will print all columns by default, you can actually remove that, and the default action is to print and to print everything by default. So this is almost like saying grep TTY, right? This would be almost the same thing as if you were to say grep TTY, right? The grep command's a little bit more simple, but the grep command, at least as far as I know, doesn't allow you to split out columns. So you can grep like this, or you can use awk. This is basically the equivalent using a regex and awk. So that's that's all fine and great to understand. So yeah, and another example here of selecting columns, I actually already did this, but I'm gonna paste this in just to be complete. Yeah, here we go. TTY print columns 3 and 5. Just to copy and paste that out of my document. And now, say if you want to print everything, you just want to run an awk command that prints everything. It's not really filtering anything out. It's not really splitting everything, but this will just demonstrate how you can run a command like this: psef, pipe it to awk. Now your regex that you want to match against is empty, so it's going to match everything. Now at this point, there's almost no point in even using awk. You may as well have just gotten rid of awk like that. So it does rearrange the order of the output a little bit, but in any case, you're basically getting the same thing. So basically, if you don't specify the command to run, by default it prints it out, and if you don't specify a regex in here, by default it matches everything. So it's just worth being aware of that behavior. Now, say if we want to count lines that match a certain pattern and print the total, right? So we're going to use a command like this. I'm going to copy and paste this command in here. Let's see, paste this guy. Whoops. All right, yeah. So paste this command in here, right here on the bottom here. So we have PSEF, pipe it into awk, and we're going to search for the word test. And every time it finds the word test, it's going to run a command it's going to run a command ++ C. So it's going to increment a variable called C. So basically, it's going to match. This is the match. It's going to match this regex, and then it's going to. This is the command it's going to run for every line in the file that matches. It's going to run that command, and all that command does is increment a counter, which is that variable C. And then in the end section, it's going to print the total. So this runs once at the end. It's so you have your end block here. It says print, and then you print a string saying total matched, and then you print the actual value that you want to print, which is C, which is this variable that we were incrementing. So let's give this a shot, and so total match 2. So there are two things that match the word test. Now, so let's say if you were to PSEF grep this, grep for the word test, you're going to see test in here twice. So there's kernel ops test. So this is one thing that matches it, and then there's the actual command that I'm running that matches it. So if you do the same thing with awk, like say if you just wanted to match this, you could say you'd actually remove this altogether and just see what matches. 2 lines that match test. So if you want to count them up, you can just print them out like this. So this is a use for an actual variable, an example of something other than just printing out columns. So pretty good example there. Now let's say if you wanted to print the number of times that you match the word root, right? 178 times. So there's 178 processes with the word. So most of the times it matches root, you're going to see it's matching the user root here. So it probably occurs somewhere else in the output too, but there's a lot of processes running as root. Now let's say if you wanted to match the user1, which is what I'm logged in as, user1, you could get the 100 processes as my own user. So I'm running a desktop Linux system. There's a ton of processes running as myself just to get this desktop logged in and running. So for this GNOME session that I'm in right now, yeah, 100 processes apparently just running as myself. So if you could also do this with a file. If you want to count all the lines in a file that match, you can pretty much just total them up like this, which is pretty useful. Now, normally if I wanted to do that on the command line, I might grep a certain value, and then I might pipe that into the WC command. So an alternative for that might be like psef rep user1 wc-l does basically the same thing, 101, and I mean minus the thing where we included the label where you said total matched, but it still gives you the basic value. So this is normally how I would do it using 3 separate programs. You're basically launching PS, grep, and WC and piping between them. That would be the normal way. But if you want to do all just in awk, you're still going to be piping from PS, but you're going to pipe it directly into awk. So awk is doing the job of both grep and WC. Now, there may be something, I don't know offhand, but there may be something in the grep command that allows you to count as well. So that would be something to look into on another date. In any case, useful stuff you can do with awk. Now, and a lot of these things you can do in awk, you can actually save these in a file and execute them as a script. So when you come up with more elaborate things, you can just run them as a whole script. Now, let's see, moving along here, let's see, where did we leave off? So we printed everything. All right, we've done the totals. All right, let's say if we wanted to, let's see, only print lines with under 100 characters, right? So you can print the length of a line. Oh, another thing that you should be aware of, I should probably show you this really quick right now. If you, let's do, I'm just gonna run a command, awk. I'm just gonna say awk, and I'm gonna say print $1. Now we've already done this. This is the simplest command you could run. Print the first column, right? Now, what if you print column 0, right? Column 0 refers to the whole entire line. So it refers to everything. So that's the same thing as just running print. So if you just run print, or if you were to just run no command at all, actually no command at all does nothing, but and yeah, anyway, if you match something, then it's gonna, nope. Anyways, if you were to run print, it prints the whole line. If you were to run print 0, it also prints the whole line. Now that might seem useless, but it's not useless actually. There's a reason why you would want an actual variable instead of just relying on the default behavior of print. So the default behavior of print is to print everything, and there's an actual variable for that. Now you can actually use a function called length, L-E-N-G-T-H. So we're going to pass this, we're going to call this function and pass the value of the entire line to this function. So this is going to give us the length of the line, right? So for each line in our output, this gives you the length of each line, which is kind of neat. You see most commands on average are 72 characters long, but one that's 500. Yeah, we have a few of them that are 539. Interesting that each of these long lines is 530. There's some consistency with the length of lines here. But any case, so that's kind of useful. I could see a lot of cases where maybe you have to like parse a spreadsheet and see how much data is on each line or something like that. But any case, not useful with the PS output unless, you know, just it's only useful for demonstration purposes for that. But you could actually use this for a real actual purpose if you're parsing output file from a program that generates data or a spreadsheet or something like that. That's where that would come into that's where that would actually be useful. So anyways, worth being aware of that you could do that. But the other thing is you can actually you can use this to isolate long lines. Now, for example, in the PS output here, there are a lot of short things like KWorker and stuff like that, Voco screen. Voco screen is actually what I'm using to record my screen right now, but there are some long lines, like say if you wanted to isolate the long lines, like these Google Chrome tabs and stuff like that. So you could isolate them by looking for lines with a lot of characters. So you could take this command where you say length, where you print out the length, and you could actually add a constraint on there. You could say length is smaller than 100. That will give you short lines, right? So that will, let's see here, that's not quite what we want to do. That'll print the length of any line that's under 100. But PSFE awk, you could actually, okay, so what you'd want to do is you'd want to filter this like this. I'm just typing, I should have copied and pasted, but I have to pay attention to what I'm doing. So anything, so you can't put it in the curly brackets or it's going to try to print it. So in any case, it's going to treat it as a command. So this is a function we could use to filter things out. So rather than using a regex, so basically what comes before the curly brackets is, so you could put like your curly brackets here, right? And you could say print. So before the curly brackets, you're going to have your filter section. Now this could be a regex like we showed before, or it could be an arbitrary constraint like this, just some expression that you define. So this will print out any line, any line that has fewer than 100 characters. Now say if you wanted long lines, you could say larger than 100 characters, and that's going to isolate all the longer lines. If you want the really long ones, you could say 500, right? So that's kind of useful if you're looking for things like, say, Google Chrome tabs. I mean, really, you would just want to grep for Chrome or match for Chrome one way or another. But yeah, that's something you could do. So next thing I would probably want to show you is substituting values. So we're gonna look for any line that has user1, and we're gonna swap the string user1 for user2. So we're going to use a command that looks like this. So we have pscf, and we're going to pipe that output to awk again. And we're going to run the command. The command that we run on each line is going to be sub. So here we're actually running two separate commands. First, we're going to sub. So this is going to substitute one output for another. Now we're going to match this regular expression user1, and we're going to replace it with this string user2. And then we're going to print that line, right? So user2. Now there is no user2 on this box, but we're printing out user2. So whereas by default it's going to show you user1, we're just replacing that in the output. So for example, you could actually replace root with x's, right? So you see the x's there in the output, or you could say something like ABC123, right? And ABC123 instead of root, right? So you could replace say kworker with something like that. So that's kind of good to be aware of. A nice trick to be able to do. I should also probably demonstrate this. So running two commands. So let's start with one command. So print. Now normally you just print. You just specify the columns you want. Say like column 1 and column 2, right? So if you just wanted column 1 and column 2, you could do it like that, right? Or I believe you can do this. Print. So here we have we can print column 1 and column 2. Now notice these are now printing out for each line matched. It's going to print this one, print this one value, and then print this value. So each of these are on a separate line now, but each of these we matched these in a single line and we printed them out on separate lines, right? So this first print command, printing the first column, prints all on one line by itself, and then the second print command prints on another line. So interesting thing to be aware of anyways. So let's go over some more useful commands. So we've already actually covered this before, but I'm going to cover it again because I'm going in order of my document. So you can print, just print by itself will print everything, right? And you can print 0, also prints everything, right? Now, if you want to do nothing, you can say awk and operate on a file, and this does nothing, right? You could also take, you do the same thing with your pscf output. pscf, pipe it to awk, does nothing, right? Now, let's see, what else? If you wanted to print all global variables, you can say, you can paste this in here, and you can say awk-d, and all right, I am actually not sure why that's not an option. All right, I think this was different on the system that I initially tested this on. All right, so anyways, I believe this, so when I wrote this document, I was using Mac OS, so I was using the Mac OS version of awk, and this is the GNU version of awk, or GNU version of awk. So assuming that's the difference here, but I could not find any reference to this in the man page for Linux. So yeah, I'm pretty sure that's just a difference there, so good to be aware of. Any case, we're going to move along to the next section. Actually, real quick before we move on to the next section, I'm going to show the awk-help command. So also not an option apparently in the GNU version. Anyways, so moving along to the next section, we are going to look at creating an actual awk script. So we're going to call this test1.awk. So I'm going to create a new file here. So we're going to VI this. You could edit this in any editor you feel comfortable with, whether you prefer, Nano, Pico, VI, Emacs, gedit, whatever your favorite text editor is. And we are going to create a script. We're basically going to follow the same format we used before. And it's going to look, instead of all being on one line, this is why the different sections they make a little bit more sense when you can see them spread out like this. So notice we have our begin section and our end section. So at the end, we actually did this. This is one of the earlier examples that we demoed. Now we, uh, we did this all on one line, so it was a little bit harder to read. We're going to be running this in a file. It's a little bit easier to read like this. So anyways, begin section, end section. The end section we print out done, just like we did before. In the begin section, we print out the column, we print out the header with all the column labels. So it works exactly the same way as we demoed before. Now in the middle section, this is what operates on every single line of data that we're processing. And this will first, it matches against this, which it could be, as we saw, it could be an expression, it could be, you know, arbitrary criteria or whatever. And in this case, we're actually using a regex to match against. So anything that matches this regex, we are then going to, any line that matches this regex that we loop through, we're going to run this command for. So we're going to run the print command, and we are going to print out these columns separated by tabs. Now notice, since this is in a script, I don't have this all enclosed in single quotes. So we're going to save this, and that's our nice little script that we have saved there. Now let's see here. In VI, we see, you know, it has some nice syntax highlighting, which is all fine and great. We're not going to see that in the catted out output. So to run this, we can actually, so I'm going to first show you how you would run this with a file. So we're going to specify, now this isn't going to work, but let's see, clear this out. Now our file, so now we have two files in the directory we're in right now, both called test1. We have test1.awk and test1.txt. So this first file is the script we just created, and this second file is the data file that we're operating on. This is the same one we were operating on before. So this is just, you know, this parameter is just base. You just place this in here. You don't need any switches for it. But you do need a switch. You use the -F to specify a file for your script. So the -F, specify the file for your script, and then just a positional argument for the data file that you want to read in. Now we're basically going to be running this awk script on this data file. So let's give it a shot. And it didn't match any lines because we'll fix it so that it does. We're going to come back to this in a sec, but it just printed the header and the footer in the end section, so the begin and end section. So any case, let's try this actual awk script is meant to filter out PSEF output. So we're going to run PSEF and pipe the output into the awk command, and in this case we're just going to run a -F, specify the location of your awk script that you want to run, and we're not specifying any data script because we're piping the output into awk. So let's give this a shot. And here we go. This is what we were expecting. So we're printing out these columns. So columns, let's see, 2, 3, and 7. And I labeled them as column 1, 2, and 3. But if you look at the script here, they are columns. So I'm labeling them as 1, 2, and 3, but they're actually columns 2, 3, and 7 from the output of PSEF. And so first, what this does, it matches any line with a TTY, which we did before, and it will print out these columns for any line that matches that. Prints the header, prints the footer. So that's all fine and great. Now, say if we wanted to change this, so let's look at our output really quick. Let's look at our data file. So cat test1.txt. So we see there's a bunch of lines that contain the word walk and run. So let's see if we can. Let's edit this script again. And let's try to match walk, right? Match the word walk. And let's run this again. So we're going to say awk-f, specify our awk script, and specify our data file, right? We run it, and there we go. These are all of the columns that happen. These are the selected columns for all of the rows that happen to match the word walk. Now we could edit this again and include the word run. Run it again. These are all the columns with or all the rows with the word run in them. So, and you're not seeing the word run because that was a column. Let's see, 1, 2, 3, 4, 5, 6. So column 6. So you match something that we expect to be in column 6, but it really could be anywhere in this whole row. Once we match that in the row, then we're printing out the columns that we want. So pretty simple stuff, right? So that's how you can actually write an actual awk script. So you can make that as elaborate as you want, add in all kinds of things like counting up variables and stuff like that. All that stuff that's kind of messy when you do it on a single line, you can use an actual script like this. So that's kind of nice. Actually, let's try to make this a little bit more complicated off the top of my head. Plus plus C, and I forget offhand. I think yeah, semicolon should separate these. So let's say print C. Let's see if this actually even works. And block. Okay, it assigned that. Okay, all right, it kind of makes sense. All right, yeah, so to do that, we actually need to remove this dollar signs. We're just printing C at the end. So to print the variable C, you just specify that variable. So you specify like this and like this. You don't need a dollar sign unless you're specifying the column. So let's write this out and run this again, and there we go. It prints it will basically prints your header from the begin block, all this each matching row. It prints done from the end block, and the end block also includes a line that prints out the count of matched rows, which is 6. So it prints out 6. So that's basically how many we had. We had 1, 2, 3, 4, 5, 6. So that's that. So another example of how you could make it a little bit more elaborate, right? It's a little bit more elaborate of us, and you can just keep adding more stuff like that. It becomes basically like a real scripting language, not quite at the level of Bash, and definitely not like the level of Python and Perl, but still a scripting language nonetheless. It's more than just a simple command on the command line that splits out columns, right? So it is a real actual scripting language. Any case, so let's move along here to, so we've covered scripts. Now we're going to go over flow control, which if you're creating scripts becomes, that's another reason to be creating a script. It's a little bit more tricky on the command line. So let's see, x equals 5. All right, so we're going to print out this more elaborate command here. Okay, so we're going to say, in our begin statement, we can set an arbitrary variable x to 5, and then we can say if x times 2 equals 10, so basically 5 times 2 equals 10, then it's going to say true, and if this is the case, it's going to print out matched, and then it'll print out x, which is the value, it's the variable that we have here. So basically, if this expression is true, it is, and this is all happening within the begin statement. So we're not even piping any we're not piping any data in here, and we are not reading in any file or anything. So really, we're just running what's in the begin statement once, and that's it. But we're basically running a simple expression. Now I know this is kind of so simple it's pointless, but it just illustrates how you can assign a variable and run an expression, and you can obviously see what that expression will be. Obviously this is true, so if it's true, it will then print out the value of this variable, which is 5. Okay, so that's pretty straightforward, right? Gives you a feel for how you can use like if, an if statement. Basically demos printing out, assigning a variable, printing a variable, and using an if statement. Now we can also check for string equality rather than just checking an integer like that. So you can say x equals xyz. If x equals xyz, print matched, and as expected, same thing, xyz matched. So super simple there. Now we can run a little bit longer of a command here. Let's see if this even works on a single line. All right, so there we go. All right, so basically we ran a command awk begin, all in the begin statement, x equals 7. If x is bigger than 5, print over, else print under or equal. And it prints over because 7 is larger than 5, right? So just some more logic there. That's how you can, I mean, I guess that's how it would look if you use multiple lines, and that also demonstrates an if else, right? You can use if this condition, else that condition. Now, really, you would probably want to be matching a line or extracting a value from a line or something along those lines. In any case, let's do a longer example here. So you can check for multiple conditions. So we're gonna show you how if, else if, and else work, right? So here's another example. Paste this in here, and there we go. It is 789, right? So this is just some simple logic, right? X equals 789. If it's this, print it's 123. If it equals this, print it, right? It's just if it equals to this, print this, right? Super simple, right? Just gives you, this is the basic syntax for if-else logic in awk. Anyways, that basically shows you how that works, and you could use that for more elaborate things, but yeah, you could say like if the count of a line, like you could remember how we showed you how you use a counter to count the number of lines that match a certain value, and you could say if a certain number of lines, if over a certain number of lines match a certain value, you've had a certain number of occurrences, like say if you were trying to match the keyword error or something like that. If you have over 10 errors in a log file, report it as an issue or something like that. This is the kind of just to give you an idea of what you might use this for. So yeah, that's basically it for flow control. That's as deep as we're going to go with flow control. We are now going to move on to arrays. So let's see here. Arrays. Let me basically just paste another command in here. All right, paste this in here. Now, all in the begin, this is just to show you how the syntax works. So we're going to be doing this all within the begin block. Now you have an array called array1, and this is basically like a hash, right? This is how arrays work in awk, and basically you could use as a key, you could use a random string or a number or whatever you want, and you can assign other random strings or values to it, right? And then we're going to assign 3 values to 3 indices in this array, or 3 different keys in this hash, right? And then we're going to print out the value at this key value, right? At the key value of tree. It's just a random string we chose. So it prints out green, red. Okay, so print array1 tree. It's going to print out, so print array1 and separate it by space and array23. So that's going to print out this and this. So that's green, red. That's basically what we got, right? Green and red separated by space. So that's how you can assign things to different places in an array and then print out what's in the array. You can delete a value like this if you want to. So just more array operations. You can assign a value and then delete that value like that. Okay, so whoops. All right, so let's see here. Arrays can be indexed with a key. If the key is an integer, it will be converted to a string. So we're basically always just using hashes, right? We're not, it's not like a real array. Anyways, I'm going to print out 3 commands, and these 3 commands do the same thing. So first command is going to look like this. 10, right? So notice here we had a string in each of them, indexed with a string. Here we use a string and a number, and a number. It gets converted to a string. The index is converted to a string every single time. So these are all equivalent lines. Now, multi-dimensional arrays don't really exist in awk, but they can be simulated by passing a value that looks like this for the key, and it'll be converted to a string. So I'm going to show you that right here. I'm just going to paste the value here. This is the example from my document. So awk begin. So it will look like a multi-dimensional array. You can index something. You can have the index 1, 2. So that looks like you're assigning something at this location, but really this is going to get converted to a string, and you're just accessing something at that string location. So you're kind of simulating a multi-dimensional array, but it's not a real multi-dimensional array. And there you go. So that's how arrays work in awk. Now, I know I feel like I should be doing way more elaborate stuff, but really I'm just trying to cover all of the different things you can do with awk. I'm going to cover all the details, but as far as coming up with super big, elaborate scripts with awk, we're going to mostly leave that out. You can use these pieces that I'm showing you to piece them together and come up with something much bigger and much more elaborate if you wanted to. Well, I'm basically showing you how all of this stuff works. So, I mean, these are basically just examples that show you the syntax, and you would need to actually use this to implement something on your own. So, any case, loops. So Bash does have loops. So you could actually, well, I mean, obviously there's the main loop that will, you have your begin section and end section, and then the main section of your awk script will loop through all of your data. But you can also put another loop in your, I'm going to show you in a quick example here of a for loop in Bash. Now notice this for loop is, so it's about the simplest for loop you could come up with from any language. And this occurs all within the begin statement, right? So you're looping within the begin statement, assign an initial value to a variable, assign a termination value. So it terminates when C starts out as 0, and it will terminate when it's less than, or it will continue looping while C is less than or equal to 10. So as soon as it's over 10, it's going to terminate. And with each pass of the loop, C will be incremented. So we have C++, that means increment C by 1 each time this command is run. So each time you go through the loop, it's going to increment C, and each time it goes through the loop, it's going to print out C. Now you could actually place this inside the main section of an awk script. So for every row that you match, it's going to run this script. It's going to run a loop. So you could, for example, inside this loop, you might have multiple checks. So you could run a loop checking multiple things per line if you wanted to. So just to give you an idea of what you might use this for. Any case, we're going to show you how a while loop. We also have a while loop in awk, and this basically does the same thing except it's a while loop, right? So instead of a for loop, like with a for loop, you assign your initial value, your termination value, and the increment for each time each time you loop through it. And this doesn't have to be C++. It could be like C plus equals 1, or plus equals 5. You could increment by 5 each time if you want. You could also initialize this to be a different value if any value you want, right? So anyways, similar thing with a while loop. You set your initial value outside of the loop before the loop. So you have to have a variable already set and or initialized, and then you're going to say, wow, this condition is true. So it doesn't have an initial value. So like the for loop has an initial value and an increment expression defined in here already. The while loop is only going to take this part. So the while loop only specifies your condition for continuing the loop, and you will have to initialize it yourself before the loop. And then within the loop, when it's running whatever command the loop is supposed to run, like in this case it runs print C, and then it will run your C++ right there. So that's basically how you do a while loop in awk. Now there is also such thing as a do while loop. Very similar thing. So it's going to do this, and it runs while, so it checks this condition. So after each time it runs this, it's basically going to run this the first time no matter what, and then after the first time it runs this, it will check the value. So it's also going to be off by 1. So you initialize this to 0, it will print this, and it will increment the value. It increments the value once before it ever even checks this. So the value is going to be 1 higher before this ever gets checked. So it will also always run the first time. So basically just like a while loop in any other language, or a do while loop. Basically the for loop, the while loop, and the do while loop work pretty much the same way they would in any other language, like Perl or whatever else, right? So any case, we can also use a break. We can break out of a loop like this. So similar to any other language, if you want to prematurely break out of a loop, so this loop will run while C is less than 100, but then you can put some logic in here saying if C is over 50, break. So it's going to terminate early when the value of C is 50. so that will only run up to 50, right? Whereas if you had if you had removed that, it's going to go all the way up to 99, right? Now you can also use continue to skip, right? So you can use the continue keyword here, and so if the value of c equals to 5, you are going to continue with the next iteration of the loop, skipping whatever is remaining in this iteration of the loop. So this is going to print c every time unless c equals 5, right? So there you go. It goes directly from 3, 4, then to 6 and 7, right? So pretty simple stuff, just like any other language. And you can tell it, another thing is the exit command. You can tell it to stop executing a script. So like if C, this loops until 10, but if C equals 5, it's going to exit this awk script early. And it's going to exit with a return value of 10 or a return code of 10, which is your error code. So there you go, hits 5 and it terminates before it can even print, right? So that is how you run loops. And now we're going to show you how to we're going to show you how to create user-defined functions. So put this in here. So auction. We have a function that looks like this, function test. So the name of the function is test, and you pass an n to it. And you can say return, and basically the only thing this function does is return n times 2. So it multiplies it by 2. And you can define this before you even have your begin block. Then in your begin block, you can say print, and you're going to print whatever is returned from this test function, right? So let's run it, and there you go. All it does is multiply so we're passing a 5 to the function test. The function test takes this parameter n, it will multiply n by 2 and return that value, giving you 10, which is what we printed out here. So pretty simple stuff. So anyways, let's give you a slightly longer example showing how one function can call another function, and it uses return values and multiple parameters. So a little bit longer of an example, and let's just run this. So basically it prints out 875. So you're going to have a function test1 that takes 2 parameters, an x and a y. It multiplies them together, assigns them to z. Now it will return z. Now on another function, main, takes a and b. It takes a and b, it will pass them to the first function, test1, and which multiplies them together, returns them, and it will take what was returned from this function and assign it to c and print c. And then in your begin block, you are going to call. So in your begin block, you actually call your first function, right? You call the function main. So you have the one function definition here, another function definition here, and you actually call it in your begin block. You call the function main, passing a value. First value is 10, second value is 20, right? So this calls the main function. So you're going to pass a 10 as A and a 20 as B. And you are then going to call, we actually don't even use these in this function, but we are going to then call the function test1, passing the value of 35 and 25. So this will call test1. It basically calls this function, passes for x and y is 35, 25, and it multiplies them together, assigns them to the variable z, returns the variable z back to here, assigned in C, and prints it out. So 875 is what you get when you multiply 35 by 25. Now you could also do something like let's just leave that for now. So that's essentially how you could use functions. That's about as far as we're going to go with functions and demoing functions. That should give you enough to work with for now anyways. Now let's talk a little bit more about regular expressions. So we can match a string with a regular expression. For example, we can say PSEF, pipe it into awk, and use a regex. This is similar to what we did before. We're just matching any line that matches root will get printed out, just like we did before. Now, you can negate that, right? You could do a line like this, and you can use the exclamation mark, meaning not. So anything that's not root. So it's showing anything without the word root in it, right? Now, you could also match any character, right? So in a regex, a dot, it matches any character. So you're going to say Google.Chrome, and basically between the word Google and the word Chrome, you can have any character in between them. So let's see what that matches. So that matches a few different things. See, like here you have Google/Chrome, and the dot matches the slash. So you could also match the beginning of a line. So for example, you could match PSEF awk. You're going to match root, but it has to be the beginning of the line, and that works. Whereas if you were to say Google, there's nothing Google at the beginning of the line, right? Now you could also match the end of a line, right? So if you want to match this string at the end of a line, it doesn't match anything. There's no word Chrome at the end of any of these lines. I bet we could match doc. Let's see. DOC, and there we go. There's one line that matches the word doc. So you have doc at the end of this line. So basically what this says, match this string, and the $, it represents the end of the line. So you're going to have this string followed by the end of the line. Or this string followed by the end of the line, which there's no occurrences of that. This represents the beginning of the line, so this string right after the beginning of the line. So what else can we do? We can match any character in a character class, right? So basic simple regex stuff. We can paste this in here, and a whole bunch of things match it. So anything with the word user and either of these characters following it, either a 1 or a 2. In this case, we have user 1, so it matches. We could also specify a range of characters. So this is basic regex stuff. This is basically the same in any language. So this is how regexes work in, say, Java, Python, Perl, or really anything else, right? So there we go. Character class 0 through 9, so anything that's a number. And so you have user followed by a number, and that's what we have right here. Now we could say anything that matches, anything that matches USE followed by any letter and any number. Now, any letter would be USE followed by an R and then a 1, which would be user 1. So that's how we match user 1. All right, so we can also use we can also negate a character in a character class. So like you see here, let's just clear the screen real quick. Now you'll see we're piping PSEF into awk again, and we're going to search. We're going to match the string user, or the regex user, and a character class 1. Now if you just wanted to match anything in the character class, like what we showed you before, you could just say 1, and note we have a user 1 here. It's going to match that. So basically it takes the word user, and any word user with this one character appended to it will match. And you could add like either of those two characters will match. So either a 1 or a 2. However, if you were to go like this and put a caret here, now remember how the caret was it actually referred to the beginning of the regex, or the beginning of the string that you're matching. That's outside of, or rather the beginning of the whole line. So that's outside of a character class. So like for example, if I were to put a caret right here, that refers to the beginning of the line. However, putting a caret in a character class behaves differently. So within a character class, some of the characters you use are going to behave differently, and this is one of them. This is a standard regex thing. It's the same in Perl, Python, awk, or anything. Now, in this case, we're saying not a 1. So it's going to match the word user followed by any character except one of the characters in this character set. So except for 1. So it won't match this. However, when we run this, we're still going to notice we matched. Let's just clear that and run it again. Now you're going to notice we still matched quite a few lines, and you might think, hey, why is it matching user 1 when it's not supposed to match anything with the number 1 after it? Well, it's because it's matching just the word user. If it finds the word user without a 1, it's going to match that. And there are a whole bunch of places in here where we see just the word user. For example, over here we have run user. Over here, yeah, again, run user, user in this NVIDIA process over here. So yeah, that's just something to yeah, that wasn't super obvious, but this is what I was matching in my document. So this is what I used in one of my examples, and it worked great on Mac OS because I was logged in as a user called user1, but I didn't have so many other processes with the word user in them. Running it on my Linux system here, I'm running into some issues. So we could change that a bit. Now, let's say if we wanted to, we can just shorten this a little bit, and we could say we could put a character class here. So an example that will work, we can shorten this and just say US and then any character in that character class followed by an R. Now in this case we have US ER. So the only character in the character class is an E, so long as it has that character between the US and the R, it's going to match. And as expected, it does match. But what we can do is we can put a caret here, and that's going to negate the E. So it can't match anything that says user, because it's going to say anything where you have a US, then any character that's not an E followed by an R. So it won't match the word user at all, and it's going to exclude all of those words. So we can run that, and that basically filters practically everything out. Let's see, what's another good example for that? Well, I think I've kind of illustrated the idea, but I'd like to sort of come up with a better example for this. So let's say if we said, we could say mar 0, and we could say character class 1 or 2, and it's going to match anything that's March 1 or March 2nd here, anything with that word there. So let's clear this so we have so anything March 1 or 2. Now we could put a caret here, and it's going to match anything that's not March 1 or 2. Run it again, and we have pretty much only one line that's not March 1 or 2. So yeah, there we go. Yeah, that pretty much illustrates that. So moving along here, that's excluding character classes, right? So we can also do a logical OR. So paste this in here, and we're basically just matching anything with the word user1 or root. So that's basically everything on here. Almost everything on here is running as either root or user1. So I mean, we could negate this like that and see anything. So we do have some things that are not, like we have systemd, NVIDIA. Actually, this is not even the is this? Wow, we do have an NVIDIA user. How about that? Anyways, yeah, RTKit, syslog, MongoDB, ColorD, yeah, ColorD. It's amazing all the little daemons they have in Linux these days. Anyways, so that is a logical OR. Let's show another thing. We could do 0 or 1 of a character. So let's just show you how to match this. And at this point, I'm basically just showing you regex stuff in general. This isn't specific to awk, but run this, and yeah, so it matches anything with yeah, so the question mark will match basically any character, 0 or 1 of any character here. So let's see here, yeah, just like that. So the character X, and it's going to be 0 or more times. So it could be 0 times, you could just have 0, and you could have, it could be 1 time, it could be like 10 times. So in this case, it's 0. And I guess what I was showing before with the question mark, it could be 0 times or 1 time. So that's why it's it's 0 times in this case. So I guess to make that a little bit more clear, you place a 1 here and it's going to match. Okay. Anyways, and if we were to put something like a Z, it shouldn't match. Let's see, or it will match anyways because it's 0 or more. So I guess the next character I'm going to show you is where I would demonstrate that. All right, so we have 1 or more, so we can paste this in here, and so the only place where this matches is the actual command running awk to match against this. It only matches itself, but all the other instances it doesn't match because it's not matching here. It only matches here, so it won't match this, this, this. So this is a good example. PSEF awk user x plus. So the character x followed by a plus. So it's either 1x, 3x's, 10x's, however many x's, but it can't be 0. And in this case, it's 0x's because the user is followed by a 1. Now you could also make that a 1, and it's still going to match. All right. So, anyways, so with this, whatever character's here, this tells it has to be at least 1 time to match, or 1 time or more. Yeah, so question mark is going to be 0 or 1, and asterisk is going to be 0 or more, so the character might be there or might not be, and a plus is going to be 1 or more. So the only one that guarantees that the character is going to be there in at least one instance is going to be a plus. So a plus could be 1 or more, but it can't be 0. Question mark is 1 or 0, and yeah, an asterisk is 0 or more. So it could be any number of that character. So in this case, it would be like 0 or 1 of the number 1, or 0 or 1 of the number 2. Anyways, moving along here, that'll probably make more sense looking at a regex reference. But any case, or when you actually play around with it. But see, say if you wanted to match any character 0 or more times. So basically what we've been doing here is we've been taking this character, whatever character is followed by either a question mark, an asterisk, or a plus, that's how many times it'll repeat. If you want to match any character at all, you would do a dot like this. So a dot matches any character. So again, if you put an asterisk here, that'll match any character 0 or more times. So if you were to put like a 1 here, it could be there's 0 characters between user and the number 1, so it's going to match. But if you were to put like an 8 here, now on this line you have between the R and the 8, you have a 1, some white space, and another 1. It still matches. It matches. The dot is any character, any number of times. Now you could change that to a question mark, and it would be 0 or more, 0 or 1, and a plus would be at least 1 of any character before the 8, which is actually, yeah, so at least 1 of any character before the 8, and let's see how many times that matches. All right, anyways, moving along here. What else do we have? All right, so greedy versus stingy matching. So one thing that you have in so apparently awk lacks this ability to handle stingy matching and greedy matching, but there are workarounds for this. So basically the way stingy and greedy matching works is this is something that I first came across in Perl, but it's the same thing in Python or other languages. Standard regex stuff. So if you put, like, say, a question mark here, it's going to try to match that as quickly as possible. So, all right, for example, let's say if I put a 1 here. Now, by default, let's say if I put like a dot plus 1. Now, by default, what it's going to do is it's going to take, uh, actually, this is going to make sense with the, all right, right like this. So I put dot, this is any character any number of times, and then a 1. So that could match this, or it could match all the way over to this next one here, or if it's really being greedy, it could match all the way to the last one. And so user is going to match this first part of the regex, and the 1 here is going to match this 1 way over here in the line. So instead of matching this here, it's going to match this way over here. And all these characters in between are going to be matching the wild card here, which is a dot asterisk, which is any any character any number of times, which is kind of not, in a lot of cases that's not, sometimes you might want that, but that's called greedy. It's being greedy. It's picking the longer match instead of the shorter match. The shorter match would be, just this. The longer match would be this whole big long thing here, right? So if you want to tell it to be stingy instead of greedy, you could, this does not work in awk, but you could place a question mark here. Now, it's still matching user, any character any number of times, and then a 1, but it's going to make this section of the regex as short as possible. It's called being stingy, so it's stingy matching, and so the stingiest, shortest match that it could find is user 1, and it'll match that. Unfortunately, apparently this doesn't work in awk, which is real unfortunate. Yeah, so but there are supposedly workarounds for this, which we're not really going over today. But yeah, I guess you just have to be careful the way you craft your regexes. But I would see this as just a limitation of awk, which is kind of unfortunate. Which is also, good reason not to always use awk in all cases. It's real convenient sometimes, but sometimes you just need Perl or Python. Anyways, moving along here, we are going to show you how to group things with a logical OR. So this is grouping and a logical OR all in one. Now, neither of those things match, but we could say, let's say if we want to do, so that was the date way back when I first wrote my guide, so I copy and pasted an example from it. All right, there we go. We match either of those, right? So this is going to match. Now, before we did a similar match to this using character classes. In this case, we're matching either this or this. So instead of putting the 0 over here and just matching any character in the character class 1 or 2, in this case, we're matching either this string or this string. Now, if we had wanted, we could even go like that and see if we can match there. Anyways, so that's basically that shows you grouping and a logical OR. So let's move along to standard variables and show you how these work. So let's see here. So I have a nice long example here for this. And let's see, I'm not sure how much of it I'm going to go over. I'm just going to go over all of my examples in order, but I'm going to drag the browser into the video and just go over these real quick. So $0 is an entire input record. We've actually used these before. We used these, so these are really just listed here, I guess. Much earlier in the video we went over these. If you scroll up a lot, you're going to see some examples using them. But usually when you print a column, you're printing like $1, $2 to print whatever field. $0 is going to be the whole row. So I guess that's pretty straightforward. And there's some other things, some other variables like RS is the record separator, and it defaults to a new line. So usually when awk runs, it loops over a line at a time, and each line is really just seen as a record. So you don't necessarily have to split it line by line. You could be instead of looping over lines, you could be looping over something else. So the way it determines that is by splitting up your input based on new lines. rstart, first match position in the string, used with a match function. Okay, and subsep, an array subscript separator character. What else? argc, number of command line arguments. You could show how many command line arguments were passed. So that's all fine and great. And here's an example of how to use argc right here. So we're going to move right along to that, and we have some other variables we're going to demo too. So I'm just going to run right through all of these. And again, if you'd rather read my document rather than watch me do this, you can just check the link in the description. So anyways, here we passed 4 arguments to awk, or 5 really, because this script is one of them. Anyways, it says total args 5. So there you go. And we're basically doing that in our begin block, and we're printing out, we say print the string total args and then the actual variable for the total number of args. So simple stuff. Anyways, argv, so that's argc. Now argv is the actual command line arguments, and 0 is the command line, is the command name, and 1 is the first argument. Now I'm going to show you what I'm talking about right here. So paste this in, and you see argv 0. So we're passing these arguments, and we have argv 0 we're going to print out. So argv 0 is awk. So we have argv is an array of all the arguments, and so argc is the argument count, the number of arguments. Argv is the array containing all your arguments to awk. Now, let's see here. So I'm going to run a couple more lines here. So 0 in that array is the actual command that you're running, which is awk. 1 in the array is a. It's your first argument that's passed, and which is kind of interesting. And b. So it doesn't count. So it views these as arguments in argv, but your actual script that you're passing to awk, it doesn't view as an argument, interestingly. Now, if you want to print all arguments, you could do it like this. Paste this in here, and we have a nice for loop here that loops over all your arguments and prints them all out for you instead of printing them one at a time. So worth being aware that you can do that. So if you want to look at conversion format or the conv fmt variable, print that out like this. Nothing super exciting there. If you want to look at the hash of environment variables, I don't know if I should really print this out on, yeah, I have no idea what's in my environment variables if I have sensitive information, so I'm not printing that out, but this is the command you would use. I'm not printing that out in this video because I don't want to print something sensitive, and I have to edit it out when I edit this video after recording. All right, so anyways, moving along here, we have, so let's see, we did conversion format, environment. Now awk end. All right, let's see. So file name is the current file name, and it shows. So if you're taking your input from std in, or which is what happens when you pipe output from one command into awk. Basically, awk is receiving input from std in rather than from a file. Now there's a variable called file name, and let me show you this right here. So if you're, in this case, we're passing a file that we want awk to take its input from, and it's going to loop over that file, and it is going to print out in the end statement. It's going to print the variable file name, which will contain the name of the file that we're operating on. So run that, and it tells us the name of the file we're operating on. Pretty straightforward. Now, what if we're not operating on a file? We are operating on std in. In this case, we're piping the output of pscf to the awk command. Let's see here, and instead of a file name, it gives us a dash indicating it's coming from std in. So that's how that behaves. Now we have a field separator variable, works like this. Now this would be what we showed you earlier on. Field separator equals, and it should just be a space by default. So you can set the field separator variable to a colon like this. When you print out the variable fs field separator, it's going to tell you the field separator is a colon. So yeah, nothing too crazy there. Maybe the output for this would be make a little bit more sense if you want like that. It shows it's a space, but it just shows you what it looks like to print out a space. So not too exciting or clear what's going on there, but that's what it's doing. It's just the default field separator. Anyways, moving along again, NF is number of fields. So let's try this. So we're basically just going over boring variables at this point in the video, but we have some more kind of interesting stuff coming up. So yeah, stick around for that. If you don't want to stick around for that, just give me a thumbs up and subscribe to the channel right now, and maybe check out some of our other more exciting videos if you know, you feel like you've gotten everything there is for you to get out of this video. But there are some more interesting things coming up. So yeah, keep watching if you want to get everything and you know, be an awk master. So any case, the number of fields, print all lines with over 2 fields, or in this case over 5 fields. Okay, so what this does is any line that has NF is the number of fields, and if NF is larger than 5, it's going to print any, it will, you know, it counts as true, and it's going to print that line. So that's the condition for printing the line. And so, you know, most of these have over 5 fields. So it's going to print them out. So let's see here, 1, 2, 3, 4, 5, 6, 7, 8. So let's say if we change that to an 8 here. All right, most things have at least 8 also. Well, all right, so this is actually going to filter a lot of our processes out. But you'll notice here, anything that just has, so normally everything is going to have like 1, 2, 3, 4, 5, 6, 7, at least 8 if it prints the program name and there's no arguments or anything else or spaces. That's going to be the number of fields. But if you have a space and then a parameter or something like it does in this line, it's going to be over 8, and in this case our awk command will print it out. So you could say over 9, and even fewer lines will be selected. So yeah, just another variable to demonstrate there. We can also print the number of fields. So for each line in our PSCF output, you see this just as expected, the number of columns is going, or the number of fields is going to be 8 in most cases, and when it's not 8, it's going to be 9, and then rarely it's another number of fields. So some of them are actually pretty long. So we have some with 22 fields. So that's a lot. That's probably like a Google Chrome process or something. Those tend to be really messy looking, just like on servers. If you're working in a Java environment, a lot of Java services tend to have really long, like they include the path for every library that they're including in the process name when you see it running in your PSCF output. Any case, let's see here. So the record number or line number. So these are the records. So we have 291 processes running. That's basically what that's telling us. So for each line, it's just going to increment it. So not too crazy or exciting there, but yeah, that's something to demonstrate anyways. Now let's try this other command here where we use rlength. There's another variable called rlength, and that is the length of the matched string used with the match function. So we're using a match function, and the string that it matches, it's going to print the length of it. And that's 2. I don't think it matched anything though. Oh, it matched this line itself, and that's it. So the length of the matched string. I see what it's doing. All right, so it prints out, it takes this string and it matches this. It's trying to match BC, and then it prints the length of the matched string, which is of course BC. Let's see just real quick if that takes a regex. See if we can put a question mark there. No. Anyways, all right. So forget that. Let's move along. Let me show you real quick. I'm going to drag the browser in here, and we have. Let's go over these real quick. So FNR, it's the same as NR, but only for the current file. Useful when working with multiple files. Then we have OFMT. It's the output format number. We have OFS, output field separator, and ORS, the output record separator. R length, the length of a matched string. Yeah, that's the one we just used just now. So those are some more variables that we aren't necessarily demoing, but just to be aware of them. Now this section that I'm reviewing now, this is all under standard variables, right? So this guide here, again, check the link in the description if you want to look at this guide yourself. If you want to copy and paste these examples, yeah, just check the link in the description. Don't forget that. Now, Gawk variables, these are only present in Gawk. So if you're using that's GNU awk or GNU awk. So this is what just about every Linux distro is going to have, but you won't find this on like BSD, Mac OS, or probably Solaris. So you have a few variables here. You can read them. You can check the reference if you want. I'm not going to go over each one in order now because that's going to be, it's even boring for me to read it. I don't think anyone wants me to read it. If you really have a use for these, you can look them up in a reference or something, but we don't really need to demo them or anything. Plus they're Gawk variables, so I feel like they're not that standardized anyways. These are like the extra features included in Gawk versus regular awk. So in Gawk would be like a superset of awk. Anyways, the one to look at here is ignore case. This might be useful if you want to ignore the case. So there's that. Now, moving on to operators. So we have the assignment operator, which is a single equals sign like this right here. So that's basically we're assigning a string to a variable and printing it out. So I'm going to move this off to the side here, and I'm just going to demo this because that's basically what we're doing today. We're demoing everything in my guide. And there we go, ABC, just like we would. So we assign a variable using the equal sign, and we then print it out. All right, so that's a working example of using the equal sign. Nothing too crazy. That's the assignment operator. Now we also have arithmetic operators. So I'm going to paste in one quick example that shows you all the basic arithmetic operators. So let's paste this in. Now we have awk begin. Everything's going to get demoed in this begin statement right here. And what happens here is basically we're assigning a value to the variables a and b, and then we're printing out different operations on a and b. So we have a plus b, a minus b, a times b, a divided by b, and a modulus b. So an a modulus b is just basically its division, and then it gives you the remainder. It will divide it without any fraction or decimal place, and then give you the remainder. So let's run this, and there we go. So this would be like 25 divided by 35, and so on. Anyways, these are all the values of each of these statements right here. So let's see here. Either of these operators work for exponents. All right, let's see here. I did not demo an exponent in that. So there are two exponent operators. I have this in a separate snippet. We're going to paste this in right here, and boom, right there. All right, so it does not like this. Syntax error. Now, this absolutely worked on my Mac. Maybe Linux does not like this. I can only, oh, you know what I think it doesn't like? I'll bet it doesn't like the missing semicolon. That can't be the case. All those other prints worked just fine. That has to be optional. All right, so 25 times 25. All right, anyways. You know what? I'm going to try this just to see. Place this in here. Doesn't seem like Okay, no good. All right, so I'm just going to point this out here, but yeah, this example worked on my Mac. It is not working now on my Linux workstation here. So that is interesting. So these both should work. This one's not working. This one is working. So if you want an exponent to work, just stick with this one. Good to have that demoed anyways. I'm not going to dig deeper on that right now, but as to why that's not working or why that's different. But yeah, syntax error at. Yeah, maybe I'm making some silly mistake. Any case, we're not going to dig deeper with that at the moment. So let's do a pre-increment, and then we're going to do a pre-decrement. So these are pretty straightforward, just regular operators like in any programming language. You can, let's say, assign 25 to A, and then B, you're going to take A, and you're going to increment it and assign it to B. So, and then you're going to print A and B. So, alrighty. Now let's try the that's pre-increment. Pre-decrement is going to be a similar thing. And let's see here. Now we are going to do post-increment and post-decrement and show you the differences. So that's your post-increment. Notice it's different. And here is your post-decrement. So post-increment, post-decrement. All right. Now, so notice what's going on here. So we are starting out with, so what happened here was that we took, so I would have thought, so I guess within this whole operation, it is, this is going to increment A by 1, so it should be 26. So yeah, actually that makes sense. So pre-increment, so it increments A by 1, so instead of being 25, it's going to be 26, and then it assigns that to B, prints out both of them, they're both 26. Exactly what you would expect. Same deal with decrementing, they'll both be 24 instead of 25. That's all fine and great. Now, for your post increment and decrement, we are going to take A and we are going to increment it, and this will increment this. What this does is first it assigns it, then it increments it, right? So that's why what is going on here? All right, so that's why that yeah that's I would have if it assigns it first. Yeah, that makes sense. So it takes the value of A, which started out as 25, assigns that to B, and then increments A. So A is going to be larger, the first one we print out. So A, this guy right here, is printing out as 26. So first it assigns the old value 25 to B. So that's why B is stuck with this old value. And the new value gets incremented after it gets assigned. So that's exactly what it's doing here. It first assigns and then increments, right? Now, same thing here, except going backwards. It assigns and then decrements. So it assigns the larger value of 25 to B, and then it decrements A, and then prints out A and then B. So that's why you get those values. And usually people are only using these increment or decrement these operators in a loop, like a for loop or a while loop or something like that. Any case, worth being aware of those operators. Now, we have some shorthand: addition, subtraction, multiplication, division, modulus, and exponent all in one. So let's print these out. Here's one big example. Now the shorthand is, instead of saying x plus, instead of saying x equals x plus 2, we just, all we'd be doing is adding 2 to x. So instead of saying x equals x plus 2, we just say x plus equals 2. That's a shorthand for that. And same thing with like everything else. This is just subtracting 2 from it, multiplying it by 2, divide, and so on and so forth, right? It's just shorthand for all of the same thing. And it does not like that one operator there. So same thing, same problem here. We're going to get rid of this line, and this should work just fine. And there we go. Now urinary plus and minus, or unary, not urinary. Yeah, that is something. Yeah, that's not what we want. Anyways, paste this in here, and what we see here is there we go. So the first one, we're just making it positive. Second one, we're making it negative. So we multiply by either 1 or a negative 1. To get a positive, to get a negative number, we just multiply by a negative 1. And that's basically what's going on here. So we're just adding this sign to the number. Now, continuing on here, we have comparison operators. So, yeah, if arithmetic wasn't exciting enough, this is like the most absolute basic stuff you'll find in any language, C, C++, Java, Perl, Python, practically everything. You have all these same operators. There are slight nuances, but it's basically the same thing. If you've been over this once for one language, you've been over it for like every language in existence. But let's continue on just to go through this for completeness. So, and then we're going to get on to some built-in functions, math functions, and other stuff you should be aware of. And then we're going to get on to output redirection, output formatting, and then that's going to be it for our awk tutorial. So, comparison operators. Copy and paste these comparison operators. All right, so here's our big example of comparison operators. So if you want to check that things are equal, use equals equals. If you want to check that they're not equal, it's exclamation mark equals. Now it's going to be different in some languages, but usually that's the operator you're going to use. And you can say like, less than or equal, greater than or equal. So that's all fine and great. Let's see how this works out. There you go. As you'd expect, true, false, false, true, false, true. Nothing too exciting. Let's move right along. Those are our comparison operators. Now let's move along to logical and or not. All right. So let's paste this in here. Awk. All right. So this is going to demonstrate a logical and. So the logical and is ampersand, ampersand. Now in some languages you might actually type out the word and, maybe in like all caps or something. But yeah, so that's basically it. So we're assigning 5 to x, and then we say if x is bigger than 3 and x is smaller than 8, print got it. And it's going to print got it because a 5 is between 3 and 8. That's basically what this is saying. If it's greater than a 3 and less than an 8, so between 3 and 8. Now, it can't be equal to those. It's got to be between them, which obviously it is. Now, a y variable is assigned to the string ABC. You're going to say if y is not equal to xyz and y is equal to ABC, print got it. And obviously that's the case, so yeah, let's take a look and see. Boom, it says got it both times. Got it, got it. So we were able to match here and match here. All right, so moving along, we have a logical OR. So for a logical OR, you have basically 2 pipes like this, 2 lines down like that. And it's the same thing. So it's if this is true or this is true. So only one of these has to be true. So if this is true or this is true. So in this case, both of these are true. In this case, only one of these is true. But in both cases, the result of this expression is going to evaluate to true, and it's going to print got it. And there we go, got it in both cases. Now we're going to use the not operator. So copy and paste. Here's my whole little snippet here. It says got it empty. So basically it says ABC, or if A is not equal to XYZ, which obviously it isn't, it says got it. Now B is empty. Now it says if b length, if the length of b is not, then print empty. So if there's no length to b, then print empty. And there we go. So basically another less than intuitive use of the not operator. Like in this case, we're saying not equals to, and we could just say not, but in this case, a 0 is the same as not. Any case, let's move along to ternary operators. So these are kind of useful. Now we're going to assign a value to variables a and b, and now we say this basically what this is saying. If a is larger than b, then assign larger to the variable c, else assign smaller to the variable c. Then at the very end we're going to print c. So basically the if is implied, and this is the condition in the if, and the question mark, you could just substitute in the word then. I know we don't use the word then in a lot of languages. And then else, the colon here is else. So this says if this, then do this, else do this. And then in either case, you're always going to print out the value of c. So it'll print out if it were larger or smaller. So it's smaller. All right. So you could change that, right? And it's going to be larger. So that changes how that evaluates. But basically, it's a ternary operator. Basically, you use the question mark and the colon to say, if, then do this, else do this. Put a semicolon at the end of your expression, and then print out the result. So you don't have to print the result, but you should probably do something with it. Otherwise, what's the point? Anyways, moving along, string concatenation. Print out, all right, hello and world. All right, so A is going to be equal to the string hello, B is equal to the string world, C is going to be A and B, and we're going to print C. So let's see how that looks. Hello world, they're concatenated together. Now notice at the end of hello, we have a space. So basically what we do is when we say two string variables, A and B, we just say A and B, we say C equals A and B, they get concatenated together. You don't have to use a plus sign or anything, and they just get stuck together. The end of one string touches the beginning of the other, and if we hadn't put this space here directly in the string, we wouldn't have a space, and they would just get stuck together. So there you go, string concatenation. Now let's try array membership operator in. So this is the array membership operator. We can check to see if a value is in an array. This is something you're going to do a lot in like Python or something. But usually people don't go anywhere near this far in awk. So awk begin, and we are going to say, we're basically going to populate an array. So 0 contains this value, 1 contains this value, and 3 contains. So basically we're in 3 indices in the array, we're assigning some values, and we're going to loop over it. And so basically we're saying for I in A, print I. We're printing the, yeah, anyways, let's just give this a shot. There we go. So in is just allowing us to take that value out of A for this loop inside the for loop. Anyways, let's move along here. So let's match or not match. All right, so let's paste this over here. Match or not match operator. Any line that contains the pattern. Okay. Alrighty. Let's try these separately. All right, so this is kind of like a rough match, I think. I haven't played a whole lot with this operator, but it looks like it's excluding any line with that contains a 1. All right, anyways, so I'm going to move the browser back over here real quick. And I'm just going to go over these. You can treat this as a reference because I'm not going to demo each one of these. So let's see here. Yeah, we have a bunch of math functions. And if you want, again, I've mentioned this a few times before. You know what? I'm gonna run this one example here. But I've mentioned this a few times before. All right, so we can get. All right, it does not like that. And I'm betting it's these quotes. Oh boy. All right. There we go. Random numbers. All right, so that's all fine and great. Anyway, so I'm gonna that's demoing how we can get some random numbers, which is pretty nice. Now this is you can treat this as a reference, and I mentioned this a bunch of times before. But if you want this document, check the link in the description. Anyways, we have a bunch of math functions. You can do like arctangents, cosines, exponentials. Yeah, truncate an int value, natural logarithms, random numbers, the sine and radians, square root, and srand, which is a random number with an optional seed value. So you can specify a seed value. So you can change this to srand, and there you go. Because otherwise, let's see, is this always going to, it's not always the same, but it has a seed value, so it's more predictable. So for you were to use it for authentication or some kind of encryption, someone could crack it more easily. So it just leads to weaknesses in software if you built a large system based on this, which you wouldn't do because this is awk anyways, but just worth being aware. Anyways, you have some time and date functions, systime, mk time, and string time, str time, right? So that's all fine and great. And you have, if you want to create date format strings, like here, you'll see this is using a format string to show you. So it's grabbing systime, and this is, so systime will get the second since the epoch, and str f time basically formats that into a date that you would like to actually read. So you can do like modulus m for month, modulus d for day, and so on and so forth. You can use hours, years, seconds, all that sort of stuff. Now this is the format string showing how you want to format it. And these are all the variables you can use to construct a format string to see the time. So you can display your time based on all of these things. You can show like the century, the month, and all this other stuff. This is all like standard Unix stuff. You get this in a lot of languages. You get this on the command line. You get this in Bash with like the Linux date command, and it's also right here in awk. So yeah, I can't think of maybe there's a situation where you would actually use this, but probably you're just going to use the date command directly and pull it into awk. If you did want to make a super compact, efficient awk script that does that, you might want to use this, and you could. So I could think of cases where you might need that, but this is kind of like a fringe edge case type thing. Anyways, bit manipulation functions. So you can actually manipulate bits in awk. You have like and, bitwise complement, left shift, right shift, or XOR. So that's all great and stuff. All these nice bitwise things. I mean, definitely useful in other languages depending on your use case and what you're doing. But if you want to do any low-level stuff dealing with the CPU, assembly language, interpreting things from assembly language, disassembling things, running things through debuggers, like computing checksums for packets, or like compiling a network packet by hand to create like custom network traffic, stuff like that, it becomes really useful. So if by some crazy chance you were using a bash script to construct network packets or something like that, and you wanted to use awk to shift the bits or to to set certain fields, you could do that. You probably would never do that, and I wouldn't recommend doing it. You're probably going to want to use a real language for that, but you could. It is here in case you wanted that functionality. So other functions, you can close a file or a pipe. You can delete an array element. You can exit the script with a return value, which is totally optional. Flush buffers, read the next line, stop and skip the next line, skip to the next file, return from a function, and run a command and return the status. How about that? So from within awk, you can actually, I kind of want to try that. I'm not trying that on, yeah, I kind of want to, maybe we should try that in this video. I'm kind of getting sidetracked here, but I'm a little bit curious now. Whoops. So yeah, this is me getting sidetracked in my video, but let's demo this. Normally I wouldn't try something like this out, but this is a long video, and we've kind of reached the boring part of the video, so let's just try something out. I have not tried this, so whoops. All right, I cannot type today, so uname. Let's try the uname command. All right, look at that. We can, and we don't even need this print statement. You can run a command from within awk. That's actually kind of neat. Don't know that it's going to assign that. I don't think it returns the value. Print a. No, that's just the. So a is going to return the. So if this command is successful, it just returns. It doesn't return the output. It just returns whether that command was successful or not successful. So if it called like an exit 0 versus an exit 1, 2, or 3 or something like that. So anyways, there we go. Shows the system, shows when I guess it was built, because that's not even remotely close to today's date. But anyways, that's kind of neat. Output redirection. So, all right, this is the last kind of, well, we have output redirection and output formatting that I'm going to show you. And that's going to be, I think, almost everything for this video. So let's give it a shot. Paste. All right, awk begin, print, testing. All right, so redirect in, overwrite. I think I just overwrote my sample file. So yeah, cat test1. Yeah, that's not, I should have paid attention to what I'm doing. So yeah, don't do what I just did and not pay attention when you overwrite files. But yeah, so you're gonna basically run awk, run this awk command. So it looks like within the begin, this whole begin block, you can say print out a string and actually do redirection within this. You don't even have to do it outside. Normally, if I were to redirect the output out of an awk command, I would redirect it, the output of the entire command after it. So at like the end of the line here, I would put a redirect. But I guess if you want to just redirect some output at the very beginning of the awk command, and then maybe you have like a central block and the end block, do more stuff after redirecting and only output this one value here, you could do it that way. So that's worth being aware of, I guess. And we could also paste. We can append. So here we're redirecting, overwriting the whole file. Here we're appending. So two of these greater than signs will append, whereas one will overwrite the file, just overwriting the entire thing. So pipe, we can pipe, you say print and pipe it to something else, to this translate command, which apparently is running an actual command. So that is interesting too. And let's see what else. Two-way communication. So this is kind of interesting. All right, paste this snippet in here. Now we have a command, translate AB, print and we're going to pipe this. We're going to pipe, and yeah, that's using some interesting syntax with a pipe and an ampersand to command. So your command is this, and you're going to print this value and pipe it into cdin of this command. And then you're going to close the command with, I'm not sure what the significance of this second variable is. Then you're going to run command, and okay, so you're going to get line out. So I guess you're taking the output of that, and then you're printing the output and then closing command. Okay, that's kind of interesting. So, oh, okay, so I think you're closing the 2. I think that's like the input of the command. All right. Yeah, so this is very, I'm not going to dig too much deeper in this, but it's kind of interesting that you can do this, and you could probably use this to do some, sneaky tricks or something, and to, make your life easier, automate some part of something that isn't supposed to be automated, or who knows, you can probably do this in a zillion other ways, and awk is probably not the tool to do it, but this is kind of neat being able to do this. In any case, that was an example I had in there for two-way communication for redirection. So supposedly what I think it's doing is it's taking, the output of your print command and inputting it into your command, your translate command here, then closing that connection to it. And then it's taking that command and you're piping the output of that command and saying get line out, and then printing the output. So you're getting a line and you're sending it to out, and then so you're getting that output and just saying getting a line of output and putting it in this out variable, and then printing the out variable is what it's supposedly supposed to be doing. Any case, yeah, very interesting command. It would be more interesting if this worked. I could have sworn I had this working on Mac OS. Wrong number in call to close. Okay, so it didn't like those ampersands at all. All right. So it translates A to B. It looks like we got the output. So it looks like that works, but it didn't close. Yeah, it did not properly close it for whatever reason. But all right, so we kind of got that working. I think the syntax was just a little bit different on Mac OS versus Linux. All right, anyways, output formatting. So you can use either print or printf. Printf gives you a variety of different formatting options. Let's see here, new line. So if you want to introduce new lines in your strings, you use a /n, just like any other language in existence. All right, so there we go. You see a new line here and a new line here. So it says hello, new line, world. So pretty simple stuff. Now, if you want to use form feed, you can use a /f. I don't believe I've ever actually had to use this for anything, but let's give it a shot. All right, look at that. It's kind of like using a tab, I guess, conceptually. So form feed, it just moves it ahead like that. Yeah, so an old thing from way back when people used physical printers. All right, anyways, tabs. So you can use a /t for a tab, /n for new line. Okay, nothing too exciting there, just spaces everything evenly. Vertical tabs, a /v for vertical tabs. There's something. Okay, there we go. Backspaces. All right, doesn't seem like that should be a thing, but it is. /b for backspace. So you would say, so for example, test 1, test 2. So so basically just prints out test 1, 2, and 3. Alrighty. Okay, so we see here there's no 1. So basically it took this second part of the string here, test 2, and moved it back 1 space. So it basically took the cursor right here after the 1 and moved it back 1 space. So the T from this part overwrote the 1 here. That's why it says test, test2, test3. So that's basically what's going on there. Um, so that's all fine and great. Let's see, it does have a test3 even though we have a backspace here and then a new line here. So in any case, it didn't overwrite it with the new line. So yeah, you can have out backspaces in your directly in your output. I can't imagine why anyone would want to do that, but you can. Any case, let's see here. You can use printf to include variables and strings. So something I could have probably not what you want to, not the first thing you want to learn about when you're learning about awk, but probably something that would have helped with some of the output statements earlier on in this tutorial. Basically, we're going to do this all in the begin block and basically assign two strings, one string to A and one string to B. Now we run the printf statement and the first parameter is the string that we want to print out, followed by two other parameters, A and B, which are both variables, right? Now within this string can contain any arbitrary text you want, except when you have a modulus and then you're going to have a modulus followed by a certain character like an S or a D, and that is going to these are spots where it's going to substitute in the variables you passed. So these two variables we passed are going to get substituted into this string at this point and this point. And that's basically how printf works. Similar in other languages too. So let's try this out. There we go. We have our string and we took ABC and 1, 2, 3, these two variables, and substituted them in here. So yeah, there we go. That's and let's just to give you an idea of how this works, you could say test dash 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 dash, right? And it would look like that, right? So arbitrary string here, you can say, you know what, let's make it a little more elaborate too. Let's say you put xxx on the end and xxx at the beginning and print it out, right? So it's going to print out a string that says xxx, the variable that we substituted, another arbitrary string, basically separating them by dashes. Oh, actually this whole thing, dashes, test, a couple more dashes, then your second variable you substituted in, and then more. Basically what you have here, right? That kind of, hopefully that makes sense conceptually. It's kind of straightforward to me, but if you've never seen it before, it might be kind of confusing. Now, I'm going to drag the browser on screen. That was the last sample or the last demo, that command that I wanted to demo. But let's see. Let's look at this. So output formatting. Now we have, this is basically the bottom of my guide. And again, check the link in the description for this guide. So we have, we have all of these formatting placeholders for use with printf. That's what I said when you substitute a variable in. These are placeholders like modulus S, modulus D. So for example, modulus S will print a string, whereas modulus D or modulus I will print an integer and truncate decimal. Okay, so it will basically, that's what we did here. This was an integer and we just substituted an integer in here. You do like a floating point number in this format. You can print a floating point number in this format. Basically all these different things like modulus G, modulus O for octal, modulus U for unsigned decimal, S for string, or hex or whatever else. And if you actually want to print a modulus, just put a double modulus there, basically to escape it. So usually a modulus followed by one of these characters will give you, each of these different things. And if you just want a modulus, just to escape it with two modulus. So you can set, you can also use a number to specify padding with spaces, and you would start that number with a 0 to lead with zeros instead of spaces. So basically like what you see here. So 5 spaces of padding, 50 spaces of padding, 5 leading zeros, 50 leading zeros. And if there's some more things you can do, you can like left justify it, show the prefix even if it's positive, and add a leading 0, show a leading OX for hex stuff, right? So let's, I'm going to try a few of these just to go over it. So that wasn't my last command that I'm going to use. So all right, I'm going to remove most of this, and I'm just going to, for my format string, I'm just going to say modulus D, just to get a real simple example so we can play with the formatting here. Now here we're just printing out 1, 2, 3. I should probably put a new line here. There we go, prints out 1, 2, 3 every time you do that. Okay, that's all fine and great. Now let's say if we want to print this in hex. So let's see, unsigned hex is going to be a modulus X, right? Change the D to an X, and there we go. 123 in hex. And you know what, I should have put my new line there. All right, so 123 in hex is going to be 7B. So if you're not familiar with hex numbers, instead of being 0 through 9, it's 0 through F, right? So it's 16 different, it's base 16 rather than base 10. So if you wanted to have a leading, let's see, you can show a leading OX in your hex. You would put instead of a modulus X, you do a modulus $X. And there you go. This is how hex numbers are often displayed. The 0x followed by the actual hex number. The 0x is an indicator that this is a hex number. So you're going to see that and recognize it right away if you're used to looking at it. So that's basically what we were just looking at over here in the guide. Show a leading 0x for hex. And to print out something in hex, you do it like this. So that's all fine and great. What else might we want to do? So octal is just base 8 instead of base 16, so it's going to look like decimal, but it you know, moves up to the tens place or whatever you would call that in a different base. But yeah, in any case, it does that a little bit sooner. Anyways, you basically only go up to a 7, right? It's 0 through 7. So let's see here. What else do we want to do? We won't, let's do some of the padding, right? So let's say if we want to do modulus 5D, all right, you know what, let's just change this to D right here. And so this is going to be 123. Now let's say if we put a 5 in here, that adds 5 spaces, right? So it's a padding of 5 spaces. And that's kind of nice if you had like multiple different numbers that you were going to display. You wanted them to all be aligned the same way or something like that. Now, if you wanted to do zeros instead of spaces, let's see, 5D, all right, 0. All right, so we could just put 0 here, right? So just basically you have the modulus and the type of variable you want to display, and then you put 5 for the number of spaces you want to pad it with. Well, you could also put 0 here, and it's going to pad it with zeros, right? So a 0 padded number, that's kind of nice too. Oh, and what 5 means is basically it's going to set it to 5 decimal places, or rather 5 characters, right? So you're going to have like a space here, so the total number equals 5, right? So here it's padding it so that the length of the whole thing is equal to 5, right? Now, if we had a number like, if we had 4 and 5 here, it's just going to print that whole thing. It doesn't need to pad it at all. But if we had a short number like this, it's going to pad it. And if we had just like, say, a 1, it's going to pad the whole thing like that, right? So that's kind of useful if you want your numbers to all line up and you know how long they're going to be. So just to make really neat looking output. So it's useful if you're coming up with reports and stuff. Probably not an everyday thing and probably not something you're going to do in awk, but if you made more elaborate awk scripts and you want to control the output, that's worth knowing. And usually when you come up with a specific requirement for your output, you'd come up with something like this, use this as like a reference and just look up the bits and pieces you need and throw them together and come up with a, something that outputs what you want. So anyways, what else could we do that's interesting? I think so we got padding. We got padding and leading zeros. Um, yeah, I don't think we want to do any left justifying or anything like that. Let's show the prefix, even if positive. So let's see if we can combine that with all the other stuff that we did. Put a plus here, and it's going to show a plus. All right. And that still adds the padding like we had expected. You could take the padding away here, take the 0 padding. It's still going to pad it up to 5, but it's going to be spaces. Now, remove that 5, and we just have a plus D, and it's just going to add a plus, whether it's positive or not. It's just going to it's going to show you know what? Let's try this with a negative number. Let's say -1. It's going to tell you that it's a negative number. Now, let's say if you remove this in the formatting, it's going to tell you it's a -1 when it's a -1, but if it's a positive, it's not going to tell you, right? So if you explicitly tell it to print the sign, it'll tell you positive when positive and negative when negative. All right, so that's, another thing to be aware of. And what else do we have here? I think that's pretty much everything we're going to cover today. So, hopefully you found this useful. Hopefully you can call yourself an awk master now. You won't really be a master until you go through and try everything and get familiar with the command. You've probably tried it out for basic things like printing out columns, and now you have the ability to use it for other things. You can do, you can use regexes and match values and print like the rest of a line and stuff. You can print out all kinds of extra things and come up with elaborate reports and all sorts of logic. And you can avoid having to combine the awk command with the grep command or the awk command with the sed command. You can do it all in awk. So instead of using awk, grep, and sed all in one, instead of piping them all together, you can do the whole thing in one carefully crafted awk command. So yeah, hopefully you can use this stuff to make your life easier, automate some of your work, make your one-liners a little bit more simple, make your Linux, Unix command line stuff a little bit more simple and straightforward, and come up with some clever things to do with awk. All right, so any comments, questions, criticisms, or anything you want to say at all, definitely leave a comment down below. We want to hear what you think. If you know something that I don't know, definitely leave a comment down below, not just for me, but for the next person who watches this video. Your comments help out everybody, not just me, so definitely leave a comment down below. If you're not sure whether or not you should leave a comment, just leave a comment. Also, give me a thumbs up, and you're going to want to hit that subscribe button and also hit the little bell icon. Otherwise, YouTube won't let you know when we come out with a new video, so you want both the subscribe and the bell icon, but you don't want to miss out on our videos. We have a lot of great content coming out. I'm going to be putting out a shorter version of this video too, like a really quick 1 or 2 minute long awk tutorial, and we have a lot of other great coding tutorials, coding videos, demonstrations. We cover like servers, electronics, basically anything tech related, networking, robots, Raspberry Pis, 3D printing, lots of great tech content. So if you want more of that in your YouTube feed, make sure you hit that subscribe button and the bell icon. And yep, that's it. So make sure you subscribe. Don't miss out on all this great content. As always, thanks for watching, and we'll see you guys on that next video.